Hi, welcome to part 3 of Learn Buffalo in Go. Today we're going to continue talking about models. That's the M in the MVC framework, Model View Controller. Last time we looked at creating a simple model, a user struct. Today we're going to talk about creating more models and creating associations between those models. Let's take a quick review of what associations look like. Okay, so let's imagine a scenario. We have a user and we have an address, and we don't want to store the address inside the user table, so we'll create a different table called address, but we do want the address to be tightly coupled to the user. So the typical pattern we might see is you create a user with some fields and it knows nothing about its address. And then we create an address table in our database with an ID, some fields, and it's going to have that user ID which points back to the user table. And typically we call this a foreign key, right? So user ID is a foreign key. What does that mean? It means it's an ID for a different entity in a different table. And that's a pattern that we see pretty commonly. So let's jump to how Buffalo might do this. Quick reminder, Buffalo is based on the Ruby on Rails framework, which uses a lot of the same patterns that we will see here in Buffalo. So this page in the documentation, Associations and Relationships, under the Database tab, gives a pretty good rundown of how some of this stuff works. If we go back to our user and address, we have one user, we have one address, right? So again, the user doesn't know anything about its address, at least the user table, but the address table does. So it does have a user ID field, which is a foreign key. So the tables are set up just like the pattern we saw before. But the Buffalo Pop plugin, similar to Ruby on Rails, is going to help us manage this relationship with this concept of has one and belongs to. So these terms suggest an order of importance, or maybe an order of parent-child relationship. So we put this arrow here to suggest that address points back to user, right? So address is sort of a child entity of user. What if we have something more sophisticated? Here's an example of a user that creates blogs, right? So one user would create multiple blogs, and each blog would belong to one user. Just like before, user doesn't know anything about its blogs, at least the database table doesn't. The blog table does. It has a foreign key, user ID, that points back to user. But what do we see that's different here? Again, the Buffalo Pop plugin is going to manage this relationship for us when we set up these values. Has many, right? Has many what? Blogs. Not blog, has many blogs. So in this case, it is important that this is plural. Over here in blog, just like before with the user address, belongs to user, right? It only has one user, so it belongs to a user. So you can imagine a couple blogs, they all point back to this same user. This is a one-to-many relationship. So let's look at something more sophisticated. In this example, each blog has a number of tags, right? These are terms. Imagine this is a blog about food, so we might have Italian food, American food, French food. We're not going to create multiple versions of those tags for each blog. We want to be able to create one that points to many blogs. So we have many blogs and we have many tags, and this relationship is known as many-to-many. So what we're looking at here isn't going to work because each blog can't keep track of multiple tags, and each tag can't keep track of multiple blogs. So what do we do? In this case, the best solution is to create a separate table that we call a join table. It only needs 3 fields, really. It has an ID to identify itself, and it has a blog ID and a tag ID. And that allows us to have many rows in this blogs tags table that would allow these many-to-many connections. Tag doesn't know about the blogs it belongs to. Blog doesn't know about the tags that it has. It's this blogs tags table that manages those relationships. So let's jump into Buffalo and see how this plays out. We're going to build off the project we had last time where we created a basic user we have a first name, last name, and age field on our user. Those are all strings. We have a basic function, full name. We have some basic validation that the fields aren't empty. And that's all we have at this point. So let's build off that first relationship, the one-to-one. So every user has an address. So what's the first step? We need to create an address struct and maybe start to add some fields and some tests for that. So how do we create an address model? We'll use the Buffalo CLI with the pop plugin to do that. How does that work? We do Buffalo pop G, and that's G for generate. Generate what? A model. What's the name of the model? Address. Anything after that is the names of the fields we want to add. Remember, by default, any field is going to be a string. If we want to modify that, we can do that here, but in this case, that's fine. Okay, so let's jump in and see what our address struct looks like. We can see those fields were created here. Our ID field. Another thing to mention is when you use the Buffalo Pop CLI plugin to add a model with some fields, by default it'll try to help you out and add some validators. Those fields should be not empty, so it's going to do it's going to add these validations. And if we look at migrations, the Buffalo Pop plugin did create a migration for us, so we do have those fields here. Again, without any overrides, these columns cannot be empty. So this is a start to create an address, but we need to create this relationship again. So how do we do that? Jumping back to this example on the Buffalo documentation website, we can see there is an example here of how they do that, right? So let's get started. So user is going to have, we'll call it user address just to eliminate some confusion. Okay, and we can see we're adding this user address as kind of a field on the struct. It's of the address type, has one address. We don't see a DB value on this, so it doesn't go in the database, right? Buffalo Pop will figure out what the address for this user is. Okay, step one. Step two, go to the address struct, and now we need to create this connection to the user. So in this case, we're going to have a user ID, which is the UUID. So we add the user ID, which does have a database key, so that helps remind us that this will go in the database. We also add this user, which is a pointer to a user. And this is where Buffalo Pop reads the belongs to, and we type in the name of that database table to help it satisfy that association. User address, the arrow, right? The arrow helps us remember that the address belongs to the user, and that's what we're creating here. Okay, so that takes care of the struct. Now we do need to modify this migration file. It doesn't have a user ID. So the user table is fine. The address table now needs to have a user ID column. And the other thing we need to add here is a foreign key, like we said before. This user ID is pointing back at the users table and an ID for an entity in that table. So here we have the foreign key for user ID, which points back to the users table, and which property in that table? The ID column. Okay, so that should be enough to run our migration. Let's try that. Okay, everything looks good. So now we need to test this, and how would we test this? How did we test the user, for example? Basically, we try to create a user, save it to the database, and run some tests on that. So let's try to do something similar with the address field. So we'll create an address. All the fields are required. Let's just fill those in now. Get the database connection from the model, the testing suite. Try to validate and create it and check that it gets an ID value, right? The database, when it saves this entity, will assign it an ID, and we can check that. We can also check that there's no validation errors. So what happens if we run this test now? Okay, so right away we get a big error. This seems to be coming from the database. It says cannot add or update a child row. Foreign key constraint fails. Okay, so by default, this address cannot live without a user. If we wanted to allow that, we would need to change the database configuration to allow null values in the user ID field. We didn't do that, so the SQL database is telling us that it cannot save this address because it needs something in that user ID field. Okay, so if we do want to maintain this setup where each address has to have a user. They don't live without a user. That's fine. We just need to change our testing a little bit here. Okay, so maybe change it to something more like this. So we have our address, but now we're going to create a user and save that address to the user. So now, instead of validate and create on the address, we're going to try to validate and create on the user, which contains the address. Okay, so what are we actually testing? We're going to try to test that the address gets an ID assigned from the database and that we have no validation errors. Let's try that. Okay, so we still have an error. Address ID is generated when saved to the database. That did not work. So what is Buffalo Pop doing? Buffalo Pop, again, tries to manage these associations and relationships for us, but we need to tell it what we want it to do. In this case, we only said validate and create the user. It doesn't validate and create the child entities, in this case, the address. It will if we tell it to, and the way we tell it to do that is through this function here. So this tells Buffalo Pop any other child entities on this one, I want you to do something for them too. Eager works for saving, updating. It also works for loading. So if we said load the user, but also load the address, we would use this eager function here. Okay, so now just with that eager, is it going to work? Okay, looks like everything passed here. That's great. One last thing we can do just to help explain how the Buffalo Pop eager method works is to try to load the address we just created and see whether the user is included by default. So down here we're adding another empty address, A2, and we'll try to find it by the ID, right? And when we do we find it? Simple test. And the second test would be, is the user loaded with it? So in this case, we're just going to test that full name function. If we have an empty user, obviously the full name wouldn't come back the same. So different ways to test whether the user is loaded, but this is kind of a simple one. So running that test over here, let's see what happens. Okay, so we're getting a nasty error, invalid memory address, nil pointer. So I'm thinking that's related to, I'm pretty sure that's related to this user not being loaded along with the address. So one way to solve that is to add this eager in front. So again, what we're doing is telling Buffalo Pop load this entity and any related entities along with it. Now let's see what happens. Okay, our test passed. So hopefully this helps kind of clear up how Buffalo Pop works and what gets loaded on each request. Okay, so now we tested the address side of the relationship between users and address. What if we wanted to test the user side of this relationship? So if we think about it, we can imagine a scenario where we have a user and we need to get their address. So we could write a simple function that takes a database transaction and tries to find an address based on the current user's ID. Something to do that is fairly simple, right? So we're going to add a method down here, get address. It takes a database connection. Maybe it's helpful if it returns an error. Create an empty address and then look up the address based on user ID. If we don't find it, return an error. If we do find it, add it to the user and return a nil error. So that would be one way to do that. If we're trying to follow test-driven development, that would satisfy the test before we've written it. So let's just comment all this out. So we have a bare function that returns a nil error. Okay. And if we wanted to write our test for that, we'll go over to our user test and do it here. So again, we need to create a user before we can create an address. Remember, those are tightly coupled. This is similar to the other test we had. We'll try to validate and create the user. We can test whether the address is saved just to sort of validate that our setup is working. But what we're really trying to do is down here. So now we want to load a user, U2, user 2, and see whether that address comes back. So here we have two tests. The first one is going to assert that there is no address, right? It's not loaded when we load the user. And then when we call this getAddress function, that it does load the user, okay? So if we run this test, Okay, so we can see that it fails. So the get address loads user address. That's what we'd assume. We haven't really written that function yet. So if we go back here, uncomment the part we had, and the test pass. Okay, that looks great. So now let's jump to the next type of relationship. This is one-to-many. So again, a user, we have the user, and each user is going to have multiple blogs. So let's set up that relationship. Okay, so our first step would be to create the blog. We can use this command here, buffalo pop generate model blog, and we'll add two fields, title and body at this point. If we run that, we would get this struct over here. So we see ID, title, body. So let's add the relationship back to the user like we did with address. So this is going to look similar. User ID, database user ID belongs to user. Okay, that's all the same. Now let's jump to the user. And just like we did for address, we're going to add blogs, but we're going to use this has many relationship. So again, it's has many to blogs, and it's plural with an S, whereas the struct itself is just blog, right? So that helps Buffalo Pop know that it needs to look up more than just one, right? Okay, so we're not making any changes to the user database at this point. We just need to create the blogs database. And this is what Buffalo Pop gave us based on that command we have. We need to add two things again. We need to add that user ID field, and we need to add a foreign key to the user's table to help Buffalo know that the user belongs there. And again, we can't create blogs without a user. We're not allowing, if we wanted to do that, we would add not null is true here, but in this case we assume every blog has an author. Okay, so real quick, how would we set up some tests for blog? This is going to look pretty similar to address. The only difference is we're going to create more than one. So we can create blog 1, give it a title and a body, blog 2. We do have to create a user in order to save these blogs, so we're saving both blog 1 and 2 on the user. And again, down here, we're going to do eager, validate, and create on that user so that it creates the child entities, in this case, the two blog entities. And we'll do a quick check whether those IDs are generated, and we have no validation errors. Okay, everything looks good. This is very similar to the one before. Okay, so that's the blog side of the relationship between users and blogs. What about the user side? So again, pretty similar to address, we're going to do the same thing. Create a user, give it a blog, try to save everything to the database, and then we can try to look up that user and see whether those blogs are loaded. Based on our last experiment, it's a safe bet that the blogs are not going to be loaded by default, so we will have to create a function to do that. Here you can see I stubbed out this getBlogs method on the user to do that for us. So here's that method. Again, it does nothing at this point. This allows us to do test-driven development, write the test first, and make sure that it fails, and then we can write the method that would satisfy it. Okay, so there it tells us getBlogs loads the user's blogs. It's failing. That's what we would expect. So let's add some code. And this is very similar to the getAddress. The only difference here is that with address, we were looking for one entity. With blogs, we assume more than one, so we're going to use this all function to try to look up all of them. Let's run the test now and see if it passes. Okay, everything looks good. Okay, so the last step here is maybe the most complicated. We need to satisfy this many-to-many association. So each blog should have multiple tags, and each tag can belong to multiple blogs. Three things we need to do. Create a tag entity, tell Buffalo Pop about the relationship between these two using the many-to-many tag, and we're going to need to create a separate table called blogs tags. Okay, step one is to create the tag model. We'll just give it a name. So we'll add that relationship this way. Again, related blogs is just kind of a helpful name for this property and not just blogs. It might be confusing to have them all kind of repeat. And we just list many-to-many. And here's where we add that table name that we need to create, blogs tags. So we need to do the same thing for blog. Okay, so again, we're adding a property blog tags, which is tags, and it has this many-to-many relationship. Okay, step 2 done. Step 3, we need to create this table. So to create this blogs tags table, we also need to create a model in Buffalo. So we can use our Buffalo pop generate command to create a model. Do that now. And if we jump over to look at the code that's generated for us, we get a very simple blogs tag struct, just has an ID, and the migration just has the one field. In order to make this a join table to connect blogs to tags, we need to add the ID for both and a pointer to the model for both. So in this case we have blog ID, pointer to blog, tag ID, and a pointer to tag. In this case, again, we're using that Buffalo pop association belongs to. So in this case, this one join table, each row in the join table only belongs to one entity, both one blog and one tag. So we use the belongs to. And we'll need to add those fields to our migration for this blogs tag table. So similar to the others, we're going to add two fields, blog ID and a tag ID, and we'll add two foreign keys in this case because it does go to two separate tables. We run our migration now, we should be set to start writing some tests to create tags. So our first test could be something as simple as what we did with our other models. Just try to create a tag and save it to the database. We don't get any errors. The database generates an ID when it saves, and we don't get any validation errors. That's pretty simple. The next test would have to be something more sophisticated. Our data model is pretty tightly coupled right now. We need to create a tag and add it to a blog, but we can't create a blog without a user. So we're going to have to do a lot of setup, create tags, create blogs with a user. Everything up to about here is really just setup. That's all something that we could move later to a fixture. There's some documentation here about fixtures, and that's basically loading a bunch of data in your database before you run a test. So that would be really helpful here. But we'll leave all this as it is for now, just to be clear what happens with each test. And so it's just suffice to say we're creating two tags. Down here we're going to create two blogs attached to a single user. We're going to add two tags to the one blog and the second tag to the other blog, and then way down here we're just going to try to load the tag independently. We're going to create an empty tag and try to find it. We're going to look for that tag 2, and then we're going to do a quick check that the related blogs property is empty, right? So those blogs are not actually loaded with the tag, and we'll create a function getBlogs that will actually do that work. So over here in the tag model I have a getBlogs function which doesn't do anything right now. So we can confirm that when we run this test here, we're going to do run getBlogs, and what we would expect is that getBlogs is going to load the blogs and attach it to the related blogs property. But with this initial test we'll see that it should fail because we haven't done that function yet. Let's try it. Okay, so the error says it should not be empty, but it was empty. Okay, so now let's add the code that would satisfy this test. Okay, so this looks a little different from the other functions we created to do something similar. What are we doing here? We're actually loading the property on the existing entity. So we already have a tag. We just don't have the child entities for the tag. So Buffalo gives us something handy here. Over here in the documentation under Associations Introduction, there is this function, you can load associations for an existing model, and that's what we're doing here. So it'll try to load those associations without reloading the original entity, in our case tag. So we've added this code, pretty simple. So now we'll go back to this test here, and we would expect that to pass. There we go. So that's passing. So we've covered a lot with associations in Buffalo. We're really just scratching the surface. There's a lot more we could do to add error checking and validation for the database as well as models in our Buffalo code. But hopefully this gets you started using your models and associations in Buffalo. Thanks.